If I consider liquid to be taken in a container, liquid to be taken in a container. Let A, B, C be three molecules of liquid such that A lies well inside the liquid, B is close to the surface of liquid, and C is on the surface of liquid. If we draw sphere of influence with molecule A, sphere of influence of molecule A, B, C, sphere of influence of molecule A, B and C. It is found that sphere of influence of A lies completely in the liquid.
Yes.
Hence, if this is sphere of influence of A completely in the liquid, it will be acted upon by equal and opposite cohesive forces from all the sides. So net force acting will become 0. Okay.
Yes, sir.
But sphere of influence of B lies partially in air. If it is partially in air, then to oppose this force, there is no equal and opposite force because air ka force is negligible. Like if this is 4, here there is 1 which is opposing, but this 3 is absent. So that will be acted upon by downward force. If I consider this, cancels each other. If I consider this, cancels each other. If I consider this, no cancellation. So there will be some resultant force acting in downward direction.
Yes, sir.
For sphere of influence C, half is in air. So it will be acted upon by maximum downward force.
Yes.
So every molecule which are present at a distance, equals to molecular range, those molecules which are present up to the distance of molecular range from the surface, called as surface film, they are acted upon by resultant downward force. Because of this downward force, stretching force is also called tension. So because of downward force, the surface behaves like stretched elastic membrane. And this film ka thickness is hardly 10 raised to minus 9 meter. Therefore, it is called membrane. Again, I am repeating. Consider liquid to be taken in a container. Let A, B, C be three molecules of liquid such that A lies well inside the liquid. Therefore, sphere of influence of A is completely in liquid. Thus, resultant force acting on molecule A will be 0. Hence, it is free to move inside the liquid. The sphere of influence of molecule B lies partially in air. Therefore, it is acted upon by resultant downward force. Sphere of influence of C lies half in air. It is acted upon by maximum resultant downward force. Thus, every molecule which lies up to the distance of molecular range, that is in surface film, will be acted upon by resultant downward force. Thus, the surface of liquid behaves like stretched elastic membrane. Clear meaning? Why it is behaving like?
Yes, sir.
Just
Yes,
draw the
sir.
diagram. Yeah, please draw the diagram. After completion of this chapter, I will start with oscillation because with oscillation only waves you can understand.
Done, sir.
Okay, right. Consider liquid to be taken in glass container. Consider liquid to be taken in a glass container. Let A, B, C be three molecules such that A lies well inside the liquid. B lies close to the surface of liquid, and C lies on the surface of liquid. And C lies on the surface of liquid. Draw sphere of influence for all the three molecules. So sphere of influence for all the three molecules. Consider liquid. Completed this one?
No,
Yes,
sir. Wait.
sir.
Okay. I'm clearing this, okay?
Sir, just 2 minutes.
Yeah, okay. Now one by one we have to write about A, B, C, and then last conclusion line. Done, Anmol? Completed?
Yes, sir.
Right. The sphere of influence A lies completely inside the liquid. Hence, resultant force acting on molecule A will be zero. Thus, it can move freely. That means there is no tension. Freely it can move within the liquid. It can move freely within the liquid. Next paragraph. The sphere of influence of B lies partially in air. Hence, it is acted upon by resultant downward force. Acted upon by resultant downward force. Yes, completed?
Just a minute, sir.
Okay. Over.
Yes, sir.
The sphere of influence of C lies half in air. Hence, it is acted upon by maximum resultant downward force. Hence, any molecule which lies within the molecular range from the surface, that is in surface film, will be acted upon by resultant downward force. Thus, the surface of liquid behaves like stretched elastic membrane. Surface of liquid behaves like stretched elastic membrane. Now copy full. Yes, done.
Yes, sir.
Yes, sir.
Now don't write anything. I'm explaining. Write a part. I will send you a written note in PDF format so that it can save our time. No, because ये आगे का पूरा part graphic diagrammatic based. Define surface tension. Define surface tension. Now, if this is container containing liquid, when I see from top, I'll be able to see this plane, which can be rectangular, which can be circular, which can be electrical, depending upon the shape of container. In this, if I consider set of points, what is set of point called as? Line? Hello?
Yes, sir.
So on this surface, there are molecules. If I consider set of points which are molecule, then this will behave like imaginary line.
Yes.
All these molecules, they are attracted by the molecule within the molecular range from both the sides.
Hmm.
This force is actually called surface tension. So force acting per unit length at right angles, force acting per unit length at right angles to the imaginary line, drawn on the surface of liquid is called as surface tension. Followed, what is surface tension?
Yes,
Force
sir.
acting per unit length, but not in any direction, at right angle to the imaginary line drawn on the surface of liquid is called as surface tension. Its SI unit is Newton per meter. What will be its dimension? Force dimension is M1, L1, T minus 2, meter is L1, so it is M1, L0, T minus 2, correct?
Yes, sir.
So now I think you followed what is surface tension. It is force acting per unit length at right angle on imaginary line drawn on the surface of liquid. SI unit Newton per meter. Dimension M1, L0, T minus 2. Write up I will send you. I'm just explaining now further. Okay. Now note. Suppose we take one needle of length L. So it will be acted upon from length this side also as well as this side also.
Yes, sir.
So can I say for needle total length in contact is 2L?
Hmm.
If it is ring floating on the surface, then total length in contact is from outside plus inside. So can I say it is 2 times circumference? Hello?
Sir, for ring now?
Ring only.
Yes, sir.
For ring 2 into 2 pi r. Suppose it is
Yes, sir.
this. Then for this what you will say? If it is this, then only one circumference. This is in contact. Ring may
Yes,
hold.
sir.
So it is
Yes.
nothing but 2 pi r. If it is ring with hole, then outer circumference plus inner circumference. Correct? है ना? ये
Yes.
outer part plus इसके अंदर भी liquid आ जाएगा inner part. So outer circumference plus inner circumference. If it is closed glass tube, then only out circumference outer वाला है ना?
Yes, sir.
If
Yes.
it is open glass tube, तो ये ring जैसा हो जाएगा ना? That means 2 into 2 pi r. Okay.
Yes, sir.
If it is metallic, a wire frame of finite thickness. So wire frame, so outer perimeter plus inner perimeter, which is twice length plus breadth, 1 perimeter into 2. Okay.
Yes, sir.
Yes, sir.
So this 7, 8 length in contact, I will give you a note in the note. That means when you see the notes, it will be given in that. No need to write right now. Now define. Are you okay with this? If I send the write-up part for the afterwards,
Yes, sir. Yes, sir.
only for this part because it is easy. Because I have to start with oscillation as fast as I can. Because oscillation जब हो गया तभी आपको wave समझेगा. फिर ये दो के बाद heat वाला, that will complete your entire syllabus. Oscillation, wave, heat, इतने ही बचेगा. Define surface energy. Define surface energy. See, I saw the news. In the month of April, 12th board exam is to be conducted. And
Yes,
in
sir.
May, 10th exam will be conducted. You also saw this?
Yes, sir. I
Yes, sir.
saw.
So I think your 11th standard will be again in April along with the 12th. So when your college gives you some timetable, some portion, so I will revise that. But before that, we'll complete our syllabus. As I told, I will complete by March end. March to April, I will do revision. Now, by this time, we'll come to know which topic is included in your exam. And then once your exam gets over, then I will start with 12th standard topic. If exam is delayed, then April month will utilize for 12th standard topic. But 15 days before your exam, I will do revision. Don't worry about anything. Because 11th this year, they may hardly include 30 to 40% of syllabus for college exam, not for entrance. Surface energy. Whenever we say energy, it can be stored energy, potential, or it can be energy of the moving bodies. Moving body का energy को kinetic energy बोलते हैं ना?
Hmm.
So when the molecule is moving inside the liquid, what is force acting on this molecule which is well inside the liquid? Zero.
Yes, sir.
So will it be opposed by any cohesive force or not? Understand? See, molecule is well inside the liquid. Then net cohesive force is zero. If there is no
Yes, sir.
force, then it will move with its speed, no opposition. So only energy possessed will be kinetic energy because it is not doing work against any opposing force. So those molecules which are well inside the liquid, they are acted upon by zero resultant force. So they are free to move, hence energy possessed is only kinetic energy. But when molecule enters in the surface film, it will be acted upon by resultant downward force. Is
Yes,
it?
sir.
So to retain themselves in the surface film, the molecule has to do work against the force. What is work done against the force called as stored energy or not?
Yes, sir.
Yes, sir.
This work done against the resultant downward force is stored in the surface film in the form of energy called as surface energy. Clear what is surface energy?
Yes, sir.
So if they say
Yes, sir.
molecule is inside the surface film, which energy it has maximum? Potential energy. If it is inside, then only kinetic energy. This type of theoretical MCQs they can ask. So if the molecule is in surface film, does it has only potential?
No,
No.
sir.
Inside only kinetic? Yes. On the
Yes.
surface, it has maximum potential and some amount of kinetic. Okay? Hello?
Yes, sir.
What will be unit of this surface energy? Joule. Any energy is in joule.
Yes,
Yes,
sir.
sir.
Yes, sir.
Okay. Now next part is very important. Obtain relation between surface tension and surface energy. Most of the college asks this for 3 marks. If not theory, then numerical based on surface tension and surface energy. Obtain relation between surface tension and surface energy. See, when you have by chance gone in gardens when you are small kid, at the entry you might find some vendors. एक वेंडर होता है जो बुड्ढी का बाल बेचता है.
Yes, sir.
सुना बुड्ढी का बाल बोलते हैं उसको, याद है क्या रहता है वो?
Yes, sir. Candy
Yes,
floss.
sir.
Cotton candy.
Candy floss.
Candy floss. Then one few persons they are selling balloons,
Yes, sir.
and you'll find some old man sitting beside. He has one cylinder like container, इसमें soap solution रहता है और उसके पास ऐसा एक रिंग जैसा रहता है. इसमें डुबाता
Yes,
है,
sir. Yes, sir.
he lifts like this, ये ऐसा फिल्म बन जाता है, फिर फूक मारता है तो इसमें से ऐसा बबल निकलता है. देखा है आपने?
Yes, sir.
Yes, sir.
तो मतलब when he dips this frame inside that solution, तो इसके ऊपर एक फिल्म बन जाता है ना सोप का. So when he
Yes, sir.
blows it, तो इसके अंदर से ऐसा बबल निकलता है. बराबर?
Hmm.
Sir. Yes, sir.
हाँ. अब देखते हैं what is surface tension and surface energy. Consider a rectangular frame of wire A, P, C, D, where 3 sides are fixed and fourth side CD of length L is movable. Means I can move it to and fro. We can slide it. When this frame is dipped in soap solution, then soap film is formed on ABCD. Any doubt till this?
No doubt, sir.
Now slowly if I pull this, then it will come to new position. Suppose we call this as C dash, D dash. By pulling it small distance dx, तो ये फ्रेम भी थोड़ा ऐसा एरिया बढ़ा देगा ना अपना ऐसे इधर, है ना? हेलो?
Yes, sir.
So if there is soap film and fourth side slowly you move, तो फ्रेम भी थोड़ा बड़ा हो जाता है ना वो सोप का.
Yes, sir.
Again I'm repeating. Consider a rectangular frame of wire ABCD where 3 sides are fixed and fourth side CD of length L is movable. It is immersed in soap solution and lifted horizontally. Then soap film ABCD is formed. Due to this film, cohesive force F will act on side CD because
Hmm.
मॉलिक्यूल खाली इधर ही है ना, पहले तो इधर ही एक्ट होएगा ना. Cohesive
Yes, sir.
force F due to surface tension will try to contract the film. This force is given by surface tension into total length in contact. ये फिल्म है, फिल्म में मतलब ये ऐसा रहेगा, थोड़ा थिक है ना.
Yes, sir.
से भी फोर्स
Yes,
एक्ट होएगा
sir.
और इधर से भी एक्ट होएगा. टोटल लेंथ ये ऊपर वाला नीचे वाला मिला के 12 कर दिया. Let against this cohesive force side C dash CD be moved slightly by distance dx. So work done against that force is force into displacement, that is T into 12 into displacement. तो ये फ्रेम इधर से थोड़ा सा बढ़ गया, तो इसका मतलब ये ऊपर से भी L dx और नीचे से भी L dx होगा. So can I say 2L dx is total change in surface area, है ना,
Yes, sir.
denoted by suppose dA. So I can say work done is T into dA. This work done is stored on the surface in the form of energy called as surface energy, that is surface energy du is T into dA. The surface tension is also defined as surface energy per unit area. This is the relation between surface tension and surface energy. Clear?
Yes, sir.
So what is relation? T equals to du upon dA. So what was SI unit of surface tension earlier? Force upon length, Newton per meter, na? Newton per meter, correct?
Yes,
No?
sir. Yes, sir.
But from this
Yes.
I can say it is also joule upon meter square. Am I correct?
Yes, sir.
So surface
Yes, sir.
tension has two SI units, Newton upon meter or joule upon meter square. Any doubt in this till this?
No, sir.
Okay. No. One drop splits to n droplets. We are interested in what is change in energy or work done. So one drop when splits into n droplets, volume of this single drop and volume of all this droplet combined is same or different? Hello?
Yes, sir.
Volume of this
Yes.
bigger drop of liquid which splits into smaller droplets. So volume of this larger and n smaller, are they same or different?
Yes, sir. Same.
Same, क्योंकि liquid है ना. जैसा if I take a container of 1
Yes, sir.
liter, उसमें से एक
Yes.
milliliter volume same रहेगा. So if this has radius capital R, this has radius small r, so volume of capital wala will be 4 by 3 pi r cube. This is n time 4 by 3 pi r cube. Can I cancel 4 by 3 pi from both sides?
Yes, sir.
So r cube becomes n r cube. Taking cube root, r is n raised to 1 by 3 into r. Now surface. So whenever you see drop becoming droplet or droplet combining to become drop, your start will be this, volume remains same. ऐसा 2-3 चैप्टर में आएगा. Now surface area of one big drop, suppose I call this as A1, will be 4 pi capital R square because surface area of sphere is 4 pi R square. Okay,
Yes, sir.
fine. Surface area of n droplets, comma A2 will be n times 4 pi r square. That is nothing but n times 4 pi. Small r is capital R upon n raised to 1 by 3 is the square. So A2 will become n into 4 pi capital R square upon n raised to 2 by 3. 2 by 3 goes up, it will become 1 minus 2 by 3, which is n raised to 1 by 3, 4 pi r square. So I got surface area of one bigger drop, surface area of n droplets. जरा एक बार देख लो, कुछ डाउट है क्या?
No, sir. No doubt.
No? We are interested in surface energy. So just now we proved surface energy is equals to surface tension into change in area. Just now we proved, if you remember. So I can say change in area is A2 minus A1. See, A2 में ना ये अलग अलग ड्रॉपलेट है, A में सब मिल जाता है, मिल जाएगा तो ये वाला पार्ट वैनिश हो जाएगा ना, कॉमन हो जाता है, बराबर, इसलिए A2 बड़ा है.
Yes, sir.
So it is n times n raised to 1 by 3 4 pi r square minus 4 pi capital R square. So 4 pi capital R square n raised to 1 by 3 minus 1 is change in area. Change in energy is surface tension into change in area. So T into 4 pi r square n raised to 1 by 3 minus 1. This is formula for change in area when one drop splits into n small droplets. T into 4 pi capital R square n raised to 1 by 3 minus 1. Okay.
Yes, sir.
So when I send the note by today evening, please copy in your book so that Wednesday when I start with numerical or explain further, there is no issue in your mind. Second point, n droplets, total n droplets collects to form single bigger drop. Collects means combines to form single bigger drop. Now again, what is same? Can you tell? What will be same? What will be same? Can you tell? Same thing, no? Volume will remain same. Hello?
Yes,
Yes,
sir.
sir. Yes, sir.
Volume will remain same. N times 4 by 3 pi r cube is 4 by 3 pi capital R cube. So 4 by 3 pi, 4 by 3 pi cancel. So n raised to 1 by 3 into small r is capital R. Area of n droplet is n into 4 pi small r square. Area of one bigger drop is 4 pi capital R square, which will be 4 pi n raised to 2 by 3 into r square. So change in area will be A1 minus A2 because droplet का area कभी भी बड़ा रहता है. N into 4 pi r square n raised to 2 by 3 4 pi r square. That is 4 pi r square n minus n raised to 2 by 3. Therefore, change in energy is T into change in area, which will be equals to T into 4 pi r square n minus n raised to 2 by 3. So two formulas you have to remember. When drop becomes droplet, then T into 4 pi capital R square n raised to 1 by 3 minus 1, and droplet combines to become drop, then T into 4 pi R square n minus n raised to 2 by 3. These two formulas you have to remember to solve numerical. Just go through it. See whether you have followed this.
Yes, sir.
Okay. Explain why surface of liquid can be either horizontal or concave, either horizontal or concave or convex. So this is horizontal. This way if I get, then concave. If I get this way, then convex. Okay, meaning of horizontal, concave, convex. So we have to explain why this happens. Few liquids are horizontal, few surfaces are concave, and few surfaces are convex. How many types of forces can be there between liquid molecules and that liquid and container? One force can be adhesive, other force can be cohesive. ना दो ही एक्ट होगा ना.
Yes, sir.
अब ये दोनों का रिलेशन से सरफेस हॉरिजॉन्टल बन जाता है और कॉन्केव और कॉन्वेक्स. सपोज this is one vector, this is another vector, then diagonal is called resultant, I think.
Yes, sir.
Always you will find the diagonal is closer to the smaller vector, larger vector. Okay, it makes less angle with larger vector. Like if this is one vector and this is one vector, and again I find resultant by drawing the parallelogram and diagonal, तो ये angle छोटा रहेगा. So I have just kept in mind resultant of two vector makes small angle with the larger vector. You also keep in mind.
Yes, sir.
Liquid has got property to adjust itself such that its surface is always perpendicular to the resultant. अगर कॉन्केव है तो पॉइंट पे टेंजेंट बनाना पड़ता है ना हमेशा. अगर कर्व है तो डायरेक्शन के लिए क्या बनाते हैं हम लोग? टेंजेंट. हेलो.
Yes,
Yes,
sir.
sir. Yes.
If surface is not horizontal and now you want to find direction of tangent at that point, then we draw tangent at given point ना. अब ये कर्व है ऐसा, तो इसका टेंजेंट ए पॉइंट पे क्या आएगा? ऐसा होएगा ना. इधर ऐसा होएगा, इधर ऐसा होगा, और ऐसा है तो हर एक जगह पे यही टेंजेंट है ना. ओके,
Okay, sir.
एकदम सिंपल है, कुछ नहीं है. See, usually there are three types of liquid. One, which completely wets the wall of container. Completely wets the wall of container. Completely wets the wall of container, such as water. Second, which partially wets the wall of container. Partially wets the wall of container, such as kerosene. Kerosene. Third, which does not wets the wall of container, such as mercury. So depending upon type of liquid, there are three different type of surfaces: horizontal, concave, convex. We have to explain how it happens. So I will say consider three type of liquid, such as water, which completely wets the wall of container. Second, kerosene, which partially wets. Third, mercury, which does not wets the wall of container. It is found that in case of water, If we draw sphere of influence at point of contact, this will be cohesive force and this will become adhesive force. ये सबका रिजल्टेंट बीच में बना है. So it is found that ऊपर वाला तो निग्लेक्ट हो जाएगा because air है. It is found that in case of water taken in a glass container, adhesive force is same as cohesive force. If both are same, where will be resultant? बीच में ना ऐसे? Hello?
Yes, sir.
So
Yes,
resultant
sir.
of these two forces will lie on the wall of container. Thus, for equilibrium, surface becomes horizontal. Hence, resultant makes 90 degree with the surface. So this is property of that liquid. Always surface will be perpendicular to the resultant. Therefore, it becomes horizontal. Okay.
Yes, sir.
Yes, sir.
In case of liquid, which partially wets the wall of container, it is found that adhesive force is larger than cohesive force. Now, can you tell me where will be the resultant? Inside the container or outside the container? Inside the water or in this thickness of the container? इधर आएगा ना ये result है ना? Close to
Sir,
the
Yes.
thickness.
pardon? It will come in the thickness of glass container, not in liquid.
Yes, sir.
Yes. अभी देखो surface को अगर perpendicular होने का है तो ये creep करेगा from that edges upward, so that tangent drawn becomes perpendicular. So for equilibrium, surface at the edges creeps upward, so resultant becomes perpendicular to the tangent drawn. Thus it behaves like concave surface. Got it?
Got it, sir.
When liquid does not wet the wall of container, cohesive force is very large as compared to adhesive force. Now resultant lies inside the liquid. For equilibrium, the surface at the edges creeps downwards, so that tangent drawn becomes perpendicular to resultant. Hence it behaves like convex surface. Thus, there are three types of liquid surface: horizontal, concave, and convex. Okay. Hello.
Yes, sir.
You all followed this concept?
Yes, sir.
Where is resultant of two vector always?
Hello, sir.
Where is the resultant of two vector always? Close to the larger magnitude, है ना?
Yes, sir.
तो if FA FC सेम टू सेम तो किसका भी क्लोज नहीं, एग्जैक्टली सेंटर पे एक्ट होएगा. FA बड़ा तो FA के पास होगा, FC बड़ा तो FC के पास होगा. ठीक है?
Yes, sir.
So with this I am stopping today, क्योंकि आपने कुछ लिखा नहीं, इससे टॉपिक थोड़ा ज्यादा हो गया. Next two lectures में will complete, and coming Monday onwards I will start with oscillation chapter. Very important chapter for entrance. After oscillation, we'll go to wave, and then we'll finally come to heat chapter. So that's all for today. We'll meet on Wednesday. Just write down homework. Please write down homework.